Okay, not everybody got the homework done, but those that did had fairly decent scores, but some things that people tended to miss, and that's what I'm kind of concentrating on with this quiz. So we're going to go over this pretty quickly. Pay close attention. You've always got the video. You can go back and see it and pause the video and all that stuff, okay? But it's real important to be able to do these things. First of all, the shape of y equals x squared. I'm just going to indicate it up here. And you just go back and look at the functions. It's a parabola. That's our x squared graph, the one that we've spent 3 weeks or 4 weeks learning to construct, okay? Make sure you know how to construct it, but also make sure you understand it as it's been done in open math. Y equals 2 to the x. Now, you wouldn't see this one in open math at this point, but you know that that graph looks like this. And the 1 over x graph is the one that looks like this. We've constructed all these graphs by creating a grid, and you really need to follow the instructions for doing these graphs and make sure you are make sure you know how to get them. But you can also get these graphs by doing a table. Okay, so just real quickly. If x equals -2, what is x squared? Well, you got -2 squared, which equals 4. If x equals -1, you got -1 squared, which equals 1. If x equals -1/2, you got -1/2 squared, which is 1/4. Make sure you know how the arithmetic works on these functions. 0 squared equals 0. 1/2 squared equals 1/4. 1 squared equals 1. And 2 squared equals 4. If you put those on a graph, you're going to get the point where x equals -2 and y equals 4, which would be here. Okay, this line is y equals 4. And of course, if x equals 2, you get the same thing. You get x equals 2, y equals 4. If x equals -1, you're going to get 1. If x equals 1, you're going to get 1. So you want y equals 1. Well, if y equals 4 here, and here's y equals 2, so when x is -1, y is 1. When x equals 1, y is 1. When x equals 1/2, y is 1/4. So where's y equals 1/4? Well, if this is y equals 1, then here is y equals 1/2. And way down here is y equals 1/4. And the arithmetic tells us why we've constructed our graph with a grid the way we have. So when x equals -1/2, we get y equals 1/4. When x equals 1/2, which is this line, we get y equals 1/4. And of course, when x equals 0, we get y equals 0. I usually like to put a red dot there. That's called the vertex of the parabola. The vertex of our graph. So there's a picture of y equals x squared. You can do similarly for y equals 1 over x. You could also do it for y equals 2 to the x. You make a table and you go from there. Okay. Now, is f of x a function? How do you tell if the graph represents a function? It means if for a function, for every x, I'm going to say x equals whatever. You could estimate it. If that's 12, that may be maybe -8 or something like that. But x equals whatever. That means you can do this for any x value. Then there's only one value of f of x. So that we take this point where the x equals whatever meets the graph, and that's y equals f of whatever. And there's only one place where the graph, where this vertical line hits the graph. Okay, so there's always an answer to what is f of whatever number you want to put into it. It's a vertical line test. Any vertical line that you draw hits the graph just once. So that's something you really need to understand. Now that's going to be prominent. You notice, I don't know if you're looking at the AI summaries of what we do in class, but they're pretty good. AI does a pretty good job. Sometimes I got to put notes in there. AI misses something or fails to say something I think is really important. I'll put italics. I'll put a comment there in italics. But you should be able to review everything I'm saying pretty much just by looking at that. It also gives you a timeline so you can see where this thing is done on the video. Okay, tells you what time to look for in the video. Okay, that's the idea of a function. And you might want to review what I said last time, at least look at the AI summary, follow up, looking at the video, or use some other resource that you need to understand these things. Okay. So yes, f of x is a function because of the vertical line test. Now, I don't want to take a lot of time on this because there are a lot of other things we have to do today. But the answer to this question is yes by the vertical line test. Every vertical line is exactly in one place. Okay, estimate f of 12. Well, here's a line x equals 12. X equals 12 here on the x-axis and everywhere above and below this point. So that f of 12 is the value that you get. F of 12 is represented by this arrow. How long is this arrow? Well, another way we can find f of 12 is to do a horizontal line here. If this is y equals 8, what's this? Well, if this is y equals 8, y equals 16 would be up here. So that this line's between y equals 8 and y equals 16, probably a little closer to 16. So I'm going to estimate y equals 13. Hopefully you can read that. So f of 12 is approximately, we'll use little wavy equal signs for an estimate. It's approximately 13, and this chalk just does not want to write good 3. Let's try again. Okay. By the graph. Solve f of x equals 8. Well, y equals f of x. So you want the point on the graph where y equals 8. Now, there might be more than one point on the graph. Horizontal line can hit the graph in more than one point, unlike on the square graph. Okay? And you have functions that we'll see later that bounce up and down a whole lot. Just trying to find a good color of chalk here. Yeah, don't like to use this one, but I will. Okay. Y equals f of x. And y equals 8. If x equals what? Well, the y equals 8 line hits the graph of f of x here. And the value of x on this line is the value of x that you would plug into the function to get 8. So what do you think x equals on this line? Well, this is 12. So this is a lot less than 12. How many of these does it take to make 12? 1, 2, about 3. So if it takes 3 times this distance to make 12, then x would be about 4 here. -4. And that's not very readable. Either chalk or my hand or both. I'll blame it on my hand this time, but x equals -4 approximately. Make sure you understand every one of these statements and how it works. Okay. Now, a graph that doesn't represent a function, draw a set of coordinate axes, and we can draw a graph that maybe does this. Okay. If the graph keeps going from left to right, then it's not going to violate the vertical line test. You're not going to have a point where you have more than one value. I'll say here, vertical line gives us more than one value. It actually gives us 3 values. We've got a value here, and a value here. Which one is it? You can't answer the question, which one is it, unless you have more information. This is not a function. Okay? So I do recommend if you miss problems of this nature on the homework, take another look at the videos for Open Math. You can do the assignment for practice. You don't get credit for doing that, but you learn the material. And if you have a question, email me about it. Now we want to go on to the idea of domain and range. We've talked about this a little bit, but not a whole lot. So let's just say we got a function. I'm going to draw a graph window here. But I'll draw an X and a Y axis somewhere. Let's just say that we got a window and the Y axis goes here and the X axis goes here. And we got a function that looks like this. Graph of a function. And there's a break in the graph. Okay? The domain for this picture consists of all the X values from here to here. That's supposed to go through the point. And all the X values from here to here. There are two intervals. There's a break in the domain. This between here and here is not part of your domain. That means that if I ask you what f of x is for this value of x, you don't have an answer. Because if you draw a vertical line through this point, you're not going to hit any part of the curve. Okay? So the domain is all points above or below points on the curve. The range between this the blue dotted line that goes through the lowest point on the curve and the blue line that goes through the highest point. Every line that we draw between those two lines is going to hit the graph somewhere. Some points are going to hit the graph twice. Some lines will only hit the graph once. But all horizontal lines between here and here get the graph. So this interval represents the range. That's just one interval. Well, whoever manufactured this chalk. Okay. Every horizontal line through this interval hits the curve. The other horizontal line hits it. That's the intuitive idea of domain and range. All the points on the x-axis above or below your curve, all the points on the y-axis that are across from points in the curve. Now, restrictions on the domain and range are mostly of this type. I'd say restrictions on the domain, not the domain and the range, because the domain is the thing that gets restricted. Restrictions, that's plural. If you got y equals the square root of x minus 7, this only works if x is bigger than 7, or if x is at least 7. You can't do the square root of a negative number. So x minus 7 has to be at least 0. Okay? So whatever you got under square root, you write that thing and say it's got to be greater than or equal to 0 and solve the inequality. Now, to solve the inequality, we just add 7 to both sides. Solve, so say you take plus 7 equals plus 7. And you add the left-hand side, you get x minus 7 plus 7 equals 0 plus 7. And that's not equal, it's greater than or equal. And you get x greater than or equal to 7. So you say the domain is the interval from 7 to infinity. That means if you got your x-axis here and you got the x equals 7 vertical line, your domain would be every x value to the right of x equals 7. So for example, x equals 10 would be to the right of x equals 7. The square root of x minus 10, the square root of x minus 7 is 10 square root of 7. I'm going to say it right eventually. Okay. If x equals 10, the square root of x minus 7 is the square root of 10 minus 7, which is the square root of 3, which is a perfectly good number. Okay. If x happens to be less than 7, like x equals 5, well, then 5 minus 7 would be negative 2, and you can't do the square root of negative 2. Actually, you can, but it's not a real number. Okay. So if you're talking about functions of real numbers, which is all we talk about in this course, then x equals 5 can't be in the domain because it causes you to have to take the square root of a negative. Okay, so your rule is if you got y equals the square root of something, that something has to be greater than or equal to 0. So I'll kind of abbreviate that. Say if y equals the square root of something, and whatever that something is greater than or equal to 0. Now it's pretty simple. If you see a square root, to write out this inequality, and the inequalities that you get in the open math assignment are going to be mostly linear inequalities that are easy to solve. Just adding the same thing to both sides, subtracting, multiplying, dividing. If you divide by a negative, you got to reverse the inequality and all that stuff, okay? Now, the algebra solving inequalities might give some people a little trouble, but it's not difficult. And if I find that you have trouble, we'll talk more about it next time. Okay. Another restriction in the domain. Okay, here's one restriction. And that restriction is if you got the square root of something, that something has to be greater than or equal to 0. Okay? Another restriction. You can't divide by 0. We've talked about why that is. A lot of the exercises you've done is that if you get, divide by smaller and smaller numbers, you get bigger and bigger results. So if you you keep making the numbers smaller, getting them closer to 0, the result is going to blow up on you and you don't get an answer. And another way of saying it is 0 doesn't go into anything. Okay. You can't make up anything by zeros. So for example, if y equals 1 over 2x plus 10, then 2x plus 10 equals 0 is forbidden. And the solution to 2x plus 10 do the arithmetic. You can subtract 10 from both sides and divide by 2. You get x equals -5. And I'm going to draw a little line through the equal sign to say x cannot be equal to -5. Those are the two main things you've got to understand about the algebra of a domain. If you understand those two things, then, if you check out the open math videos and so forth, you'll be able to do it. Um, okay, let me give you a problem to think about. Okay, if you write down y equals the square root of x plus 12 over 5x minus 15, tell me, the rules that I just gave you are you can't do the square root of a negative. Denominator can't be 0. So if you could write this down and then tell me what you're going to have to do, okay? If you can't do the square root of a negative, what can you conclude? If the denominator can't be 0, what can you say? And if you understand this, then you understand at least 80% of what you need to know for the homework. Okay, now if you're watching this, you should have proceeded. Okay, you can't do the square root of a negative. So that tells you that x plus 12 can't be negative, which means it's greater than or equal to 0. So then we can add negative 12 equals negative 12 equation to this inequality, and we get x plus 12 minus 12 equals 0 minus 12. That's and I'm in the habit of writing equalities when I do this. Okay, we get x plus 12 minus 12 greater than or equals 0 minus 12, so that x is greater than or equal to negative 12. Then denominator can't be 0. Now I've written, you can't read the word, but it's forbidden. 5x minus 12 equals 0 is forbidden. We solve this. Plus 15 equals plus 15 on both sides. And we get 5x equals 15. And we divide both sides by 5. And we get x equals 3. Forbidden. So x is not equal to 3. If we sketch these restrictions on the x-axis, we've got x equals 3. And x can't be 3. So we put a circle around the point on the x-axis where x equals 3, and we don't fill in that circle. That means that point is not in the domain. And then we've got x equals negative 12. X has to be greater than or equal to negative 12. So we put a circle around x equals negative 12, but we fill it in to show that x equals 12 is perfectly okay. And anything to the right of x equals negative 12 satisfies x greater than or equal to negative 12. Well, we can kind of draw that interval down here. X greater than or equal to negative 12, but x also has to not be equal to 3. So my interval is everything to the right of x equals negative 12 except for x equals 3. So I draw the interval like this. Up to x equals 3, and everything beyond x equals 3, but not x equals 3. So the domain is the interval from negative 12 to 3. Now, when I write this, I mean, this is all numbers from negative 12 to 3, including negative 12. That's what the square bracket means. Not including 3. That's why I use the parenthesis here. Then I say union with, and that just kind of means or. X can be between negative 12 and 3, but not including 3, or anything bad looking infinity, but this chalk isn't cooperating. Everything from negative 3 to, that's such a bad infinity, I'm going to rewrite it. But everything from x equals negative 3 to infinity. Now, open math will give you more explanation, but that's what you got to do. You got to identify denominators and you got to identify square roots. Okay? There might be a couple of other little twists, but if you do those two things, you've got the idea. If you see a little bit of a twist, hopefully you'll be able to adapt to it. And if not, we'll identify it and talk about it next time. Okay. Now that's section 2, which is a sign for probably due tomorrow or Saturday. Yeah, I've got a question. So I want to talk about rate of change. It's a pretty straightforward idea. And I believe you've seen it if you've done the assignments to date. The rate of change of y with respect to x is change in y over change in x. Okay. Now, I'm going to abbreviate that. I'm going to say ROC of y WRT x is, now another thing is, this is the average rate of change. So I'll abbreviate that. AVE for average rate of change of y. WRT stands for with respect to x is, I'll write it like this, average rate equals change in y over change in x. This little triangle thing is called a delta. It is the Greek letter capital delta. Okay? And this read delta y over delta x, the change in y divided by the change in x. If my position on I-81, that means Interstate 81. Now in my prime, if you put me out in the front parking lot, put a golf ball on a tee, put a driver in my hand, I could almost hit the ball to the interstate. Okay? I think it's a little over 300 yards, and that was kind of my limit. Okay? And now I don't know what the limit is, 12 yards, 13, something like that. Uh, uh, I haven't been on a golf course in 16 years. Still hitting the ball pretty far then, but I'm sure sarcopenia has limited me. Okay, anyhow, my point is I'm using I-81 because we're close to I-81. Okay? If my position on I-81 changes from milepost 30 to milepost 8, between 1:37, that's time, and 1:37 in the afternoon, say, and 1:50, am I speeding? What do you think? Am I speeding or not? Can you figure that out from the information I gave you? Well, how far did I travel? From mile 30 to mile 8, I traveled 22 miles, right? from 30 down to 8, it's 22, it's negative 22, and we'll incorporate that when we do the rate of change. And how long did it take me? From 137 to 150, if I'm calculating right, it's 13 minutes. If I go 22 miles in 13 minutes, am I speeding? Well, if I go 60 miles an hour, it's going to take me 22 minutes, right? A 60 mile an hour is 1 mile per minute. If I do it in 13 minutes, I'd better be running for the border, Tennessee, Virginia border. You know, one time when my son-in-law, who was Russian, this is back in the 90s, I was driving down, he's not my son-in-law anymore, but former son-in-law, he's a good guy. But uh, we're driving down the interstate, and the guy's really smart. He's really a top-notch athlete. Okay. So, and he's, 20 some years younger than I am, but we're driving along and we're doing about 60, we're probably doing 70 at least, maybe a couple miles an hour over. And a motorcycle went by us looking like he was doing 70 miles an hour more than we were. And it just kind of astonished me. He was close by me, just zipped by me. And my son-in-law just turned and said, wow. So my perception was confirmed. I think the guy was running for the Tennessee border. Figuring, we were only 15 miles from the border or something like that. He'd get there in about 7 minutes. And if anybody was chasing him, if any cops were chasing him, I don't think they can chase him at that speed anyway. It'd be too late to set up roadblocks and all that stuff. So he was probably going to make it if he lived. He's also kind of weaving. Anyhow, that's just a little color behind this. Okay, how are we going to answer this question? So I'm going to say if y is position and t is time, the average rate of change of y with respect to t is average rate is delta y over delta t. So let's do that in bigger print. The change in y from 30 to 8 is negative 22, right? Negative 22 what? Negative 22 miles, because those are mileposts. Delta t, and notice I'm using delta t instead of delta x, because it makes more sense to use t for time. So, whatever our variable is here, we call it delta whatever. But delta t is 13 minutes. Okay. Now I would subtract 150 minus 137. But those are times on the clock, and clearly 50 minus 37 is 13, okay? And you can see it's 13 minutes. That's negative 22 miles over 13 minutes, which is like 1.7 miles per minute, approximately. Okay, pretty close, within a tenth or so. 1.7 or within 100, with 1.7 miles per minute. Okay, now 60 miles per hour is 1 mile per minute. So 1.7 miles per minute would be about 102 miles per hour. Now, one thing I neglected here, it's negative 1.7 miles per minute. That doesn't mean you're going backwards. That just means you're going from higher miles to lower miles. You're going south on the interstate. That's what the negative means. Because north on the interstate, the mileage would be going up, right? So that's just an example of the average rate of change. Now, on a graph, of y equals f of x, let's just say you've got x equals a here, and x equals b here. The average rate of change of y with respect to x between x equals a and x equals b is change in y over change in x. Now, let's say this is a function. So here is y equals f of a, where the vertical x equals a line gets the graph. We draw the horizontal line. That horizontal line represents y equals f of a. And here's a point where y equals f of b. If I give you the rule for the function, you're going to be able to evaluate this. In terms of just the graph, where's delta x? Well, from x equals a to x equals b, delta x, and from y equals f of a to y equals f of b, here's delta y. If I divide delta x by delta y by delta x, that's rise divided by run. equals I got to remember that better, sorry. Left out the word average. The average slope on the interval from A to B. If I give you the rule for f of x, you can calculate this. So let's just see how that calculation would work. If f of x equals x squared minus 7, let me make this a little more rigorous. If y equals f of x equals x squared minus 7, then the average rate of change of y with respect to x on the interval from, let's say, 4 to 6 is average rate is delta y over delta x. Now, what's delta y? Y changes. Well, if x equals 4, what's the value of y? Well, f of 4 is 4 squared minus 7. That's 16 minus 7, which is 9. When y is 6, you get x, when x is 6, x squared is 36, and 36 minus 7 is 29. So the change in y is f of 6 minus f of 4. Change in x is 6 minus 4. X goes from 4 to 6. It changes by 2. Okay? This equals then 6 squared minus 7 minus 4 squared minus 7, because f of 6 is 6 squared minus 7. That's going to be 29 over 6 minus 4. Okay, so that's 29 minus 9 over 2, which is 20 over 2, which is 10. Now, you probably want a little clarification, so let me throw that in quickly. Y equals f of x, so when x equals 4, y equals f of 4, which is 9. And when x equals 6, y equals f of 6, which is 29. So delta y, change in y, is 29 minus 9 equals 20. Delta x equals 6 minus 4, which is 2. So delta y over delta x equals 29 minus 9 over 4 minus 2. I'll just say et cetera, since we're out of time, but that's a little more explanation of where this comes from, okay? That's not difficult. You just got to remember to do it. And you probably want to write it out in form very similar to the way I've written it out or to the way you see it written out in the Open Math videos or textbook, okay? So you got those two assignments. Now, I haven't been able to tell you everything, but these are the essential ideas. You're building those by videos and working the problems, okay? And your algebra looks competent to do this. Just be sure you're writing out the steps. I'll take a look at that next time. Make sure that uh, you see in the open math that I often ask you, I'm not sure I do in these assignments, but I think I probably do ask you to uh, send me well, there's a place in the open math where it says insert a picture of your work. Okay. If you can do a scan of your work, it'd be great to then insert that scan, preferably in PDF form, because I can put comments into it if I need to. Okay. Of course, if you bring it to class, I can see it here too, and I would give you credit. But I have to see it one place or another because there's 5 points of credit on that. Okay. Not sure it's on these assignments, but if it isn't, it'll be on assignments that you see soon.